And we're currently moving from 300 meters to 120 meters. And there's a position at 30 meters, which is critical. There'll be 4 or 5 maneuvers to be made in relativity, not only in distance, but also in the precision or aiming of these two vehicles before having a real connection.
What we're looking at now is a pause that's about 120 meters away. So, Professor Yang Guang, tell us what's happening at this stage.
Well, from the video, we can see that this is a signal transferred by the Tianlian data relay satellite. The video from the Shenzhou spaceship to the ground through the Tianlian data relay satellite, and now it's the simulation on the flight control center. It is a picture showing the position of the both vehicles between the Shenzhou-11 spaceship and also Tiangong-2 space laboratory. You can see that each other has already within a distance about 120 meter parking position. And under this stage, you see that before that, because two vehicles cannot reach each other, as Mr. Xu has already mentioned, they mainly on the control of the ground station. So the telemetry data can tell the ground that what position, where the position they are, and also how they should do for the next step. But now, because there are all kinds of sensors, so they can see each other and measure the relative position, relative speed, and also the relative attitude very precisely. And
so 120 meters, the Tiangong-2 Space Lab is within visual right now. So what are the astronauts doing at this stage?
Well, they are, because this time will be automatic docking, so they will not do any operations. They only, if some malfunction happen or some abnormal condition happen, they will switch to the manual docking. So this, at this moment, they will monitoring every parameter about the two vehicles and to ensure the safety. And at this stage, the microwave docking, rendezvous and docking radar, the LiDAR, and also the CCD sensors can all come into effective and can get the relative measurement of the both vehicles in all these kind of conditions, and they can recognize as the redundancy measures of each other to ensure the reliability.
Mr. Xu, next stage would be the 30-meter away pause. What would happen by then?
At 30 meters, there will be 4 or 5 maneuvers, as I mentioned. The manual mode will be switched on to standby mode rather than a full manual mode. So the automatic connection will continue, where there's a gyroscope and other equipments and high precision equipments will be switched on. Instead of the LiDAR, as Mr. Yang mentioned, there will be a high precision optical sensors that will be used for connecting these two vehicles at 30 meters. So currently is approaching from 120 meters all the way to 30 meters, and that is also in an automatic mode. And in a few minutes, we can see that these two vehicles are getting closer, because in between 120 and 30 meters, there's not much happening. It's automatic mode, and everything is done, let's say, basically by the ground control.
This time, the rendezvous and docking process will happen at an altitude of close to 400 kilometers away from Earth. So tell us about this new altitude for China, Professor Yang.
You know that for the former flight missions, because we do not stay in space for a very long period, so it is not necessary to orbiting the Earth in a very high altitude. So 343 kilometers is high enough for us to perform the experiments. So in the near future, between the Tiangong-1 and the Shenzhou-8, 9, and 10, we perform the docking at the altitude about 343 kilometers. But for the future space station, it's a different matter, because the station will orbit the Earth for about 10 years, and the aerodynamic drag will be a very remarkable consideration for the orbiting of the Earth. So the station will be higher, about 400 kilometers.
We're seeing from that image that that you're also seeing right now is a cross, and the center of that cross should be aiming at the circle that we're seeing right now, which is Tiangong-2. So, but the Tiangong-2 Space Lab, that circle right there is slightly off to the left. Why is that? Is that okay?
Because that is a very accurate CCD camera, and it can measure any attitude and position error. So from that cross, you can see how much is the deviation from the, theoretically speaking, the two axes of the two vehicles. Theoretically speaking, the two vehicles must have the zero deviation from each other. But from this cross, we can see how much the deviation is and how can we adjust the relative position. The two axes, as I mentioned, the final stage after the 30-meter parking position, the error must be less than about 18 centimeters from the final stage, because at the final stage, mainly after the distance about 0.4 meter, there will be no any control of the two vehicles. So actually speaking, they collide with each other, very natural collide with a speed range of about 5 centimeters per second to 35 centimeters per second.
Now we're seeing live images. They're up in space. That is, the two space vehicles are now 30 meters away, that they're doing the final adjustments for the precise docking of the two space vehicles. Now, Professor Yang Guang, so you've mentioned earlier that it is a very, very accurate camera on board the Shenzhou-11 spacecraft, but are there any other precise adjustment that will be taking place? Because we're seeing from that image, the circle is moving further away to the left.
Well, yes, we have many precise measurements. For instance, as Mr. Xu also mentioned, the LiDAR. And also this kind of CCD sensor, because this time the optical sensors have been improved. In the years before, you may remember that in Shenzhou-8 mission, we test the docking both under the sunshine and also in the dark area. This is because the CCD sensor can be influenced by the sunlight. This time we have already improved that sensor, and it can docking in all conditions. So this time, because the focal length of the camera is very long, so although you see that it's not just right at the center of the target vehicle, but still we can afford this error. And this time, the microwave reader is also being improved. It's much smaller than before. The mass and the space is occupied is just half than the former missions, and also it has increased its capability to have the communication functions. So this time, not only the vehicle-to-vehicle data link, like the traditional one, can work, and also the microwave reader can transmit data between each other. So they can exchange the relative parameters, such as the attitude and the speed, and also the position.
Now, like you said earlier, that this is a auto docking process, but what kind of precautions are the astronaut doing in space, Mr. Xu?
Well, astronauts are switching on a few instruments, as I mentioned, some such as the gyroscope and the manual control to a standby mode. These are just for an emergency case, that in case there's something went wrong, I have to switch on to manual mode. You can have all equipments ready. But in addition to that, we're at 30 meters between the two vehicles and flying at very high speed, about 7 kilometers per second. So what we're doing is that what we call it a near range mode, where we switch the opticals from long range to short range to make it more precise. And also we are doing 4 or 5 maneuvers to let's say, fly together at the same orbit, so that getting it ready for the final docking. So this would be, let's say, the final position before they make the real kiss.
You can see the signal change very constantly between the 3D simulation and also the cameras from both vehicles. This time we use illumination light from the Shenzhou spaceship to the Tiangong. So this time we do not need the sunlight, and we only depend on ourselves. So this time they are more independent than before and can dock in any conditions. Now we can see the data transmitted from the Tianlian data relay satellite. This is a TV camera, as I mentioned, from the Shenzhou spaceship, looking at the Tiangong laboratory. And the cross is a very precise measurement.
Now they're entering a final stage where the two vehicles, the Shenzhou-11 spaceship as well as the Tiangong-2 space lab, are making their final docking process. They are slowly approaching each other for that romantic kiss we're just talking about. So Professor Yang, in some Hollywood blockbusters, for instance Interstellar, we see some very dramatic images of an unsuccessful docking of two space vehicles in space. But what kind of event would happen if the two are unable to dock together?
Well, these kind of things do happen before. You know, the first manned space station, Salyut-1, of the former Soviet Union, do have some failure in docking because the Soyuz 10 is the first one to attempt to dock with the Salyut-1. But because the collision is too heavy and the docking mechanism has some malfunction, so they cannot enter.
Now we're seeing even closer images of the Tiangong-2. Now, and as we're seeing right now, some kind of audio communications are also.
You can see the benchmark and the cross.
This is the final moment.
Yes, they're aiming at each other at very precise angle.
They are touched.
Okay, with that,
great.
with that a round of applause, we can tell that
so
they have captured each other.
This means that the capture lock and the latch striker has connected with each other.
So the next stage would be the operation of the 12 hooks in the docking ring?
The next stage will be the absorbing the energies. You see that their impact energies, which should be less than 2 tons. But at this stage, maybe need about 80 seconds for the two vehicles to attenuate the impact forces, both on the lateral direction and on the axial direction. The lateral impact will be absorbed by the electromagnetic dampers, and the axial impact will be absorbed. The energy will be absorbed by the friction attenuators. So it is quite different. And all these mechanisms I mentioned is on the active side, which means on the Shenzhou spaceship. So the docking mechanism on the Shenzhou spaceship is heavier than the passive one, which is on the Tiangong laboratory.
How long would that process be?
That may need 80 seconds, and after that, the capture ring, the capturing ring will pull back. This procedure may need about 240 seconds. Okay.
All right, that audio says the docking ring is now retreating.
Yes, pulling back.
So there's a pulling back and locking. So once it's pulling back, it has a firm locking mechanism that needs to be conducted.
There are two stages. The first is pulling back. The second stage is pulling tightly. At the second stage also need about 200 seconds and a little bit more. And at this stage, the 12 hooks will be attached very tightly. Each hook has about the pulling stress about 3 tons. So the 12 hook will have 36 tons of pulling stress. That will be large enough for the two vehicles to attach very tightly. And also there are 2 rubber rings which can keep the airtight sealing.
Of course, all the controls are now at the Beijing Ground Aerospace Command and Control Center. But right now, at this moment, when the two vehicles have successfully, securely locked together, what are the astronauts doing?
The astronauts also, as Mr. Xu mentioned, they should do some switching operations in some of the stage. And also, as I mentioned, they must monitoring every critical parameter of this stage.
But they're also getting ready for a crossover from the passage into Tiangong-2 now. So what kind of preparations are going on?
Yes, they're previously just monitoring the docking and rendezvous process. At this moment, they're preparing for a series of activities, including the integrated body. As you probably see from this picture, that this is a camera from the Tiangong-2 towards the airlock or the connection part. between the two sides. And that little light probably is the window between the two devices. And in due time, it's currently in a locking process. Once everything is sealed, it will be pressurized and to a human habitable conditions before they open the hatch.
And the astronaut will look through that ground glass there for sneak peek into the Tiangong-2. They have been longing for a while. All right, we are seeing astronauts' images at the left-hand side of your screen right now. I can't really tell. Is that Jing Haipeng or Chen Dong?
I think sitting in the middle is Jing Haipeng. I think
Okay.
he's in command. And they have been cooped up in the capsule for 3 days. And I think they're ready to move on to stretch their legs.
Yes, of
You may
course.
notice that they still wearing the in-cabin spacesuit. That is why, as we mentioned about the possible collision, if in any abnormal condition, they can wear their in-cabin spacesuit and avoid any dangerous things happen.
It is not quite clear what they are talking about, the astronaut Jing Haipeng to the Beijing Ground Control Center.
Yes.
But at this stage, what kind of information are they communicating right now, Professor?
They are just reporting every status about the docking procedure itself and also about the vehicle. And you see that this is a camera from the front of the orbital module of Shenzhou spaceship, and the small window is the window on the door of the Tiangong-2 space laboratory. It is very interesting that in Shenzhou-9 and Shenzhou-10 mission, the astronauts were asked to use some papers to swipe the front door of the Tiangong-1, because that the Tiangong-1 has orbited Earth for a very long period. There are many things attached to this front door of the outer space. So this kind of things is very meaningful for scientific research. So it is, I believe, this time they will do the similar things.
So instead of tossing away that tissue that they used to wipe that door, they
Yes.
just keep that very precious.
Because you also know that at this altitude of the outer space, the oxygen atom can be corrosive to any material. So this kind of study is also very
长程报
meaningful for
告，
us
对
to
接机构端面
understand
密封完
the
成。
outer space, the
对接机
environment.
构端面密封完成。
So from that audio that we're just hearing right now, the sealing process has completed.
Yes. As I mentioned, we have two rubber rings can be recognized as backup or redundancy of each other. When the mechanical hooks have been hooked up very tightly, the two rubber ring can keep a very safe and a very tight air sealings.
So what will happen next after the two vehicles are securely sealed together?
So
Adding
one-
pressure?
Once the vehicles are sealed, there's one major thing that has to be done, which is to move the command and control right to the Tiangong-2, which is, Tiangong-2 is currently in charge. But because of the rendezvous and docking, there is some deviation of the orbit and speed and positions that has to be readjusted and repositioned. And all the optical sensors, radars, and even manual switches has to be switched off. So astronauts are also quite busy switching off all the equipment.
长程报告，对接机构锁紧完
So
成。
once the locking is
对
done,
接机构锁
pressure
紧
is
完成。
The audio is saying that the docking has already finished
天
in
空报
its
告，
locking
天空报
process.
告，组合体起控。
Okay, the
So what
combination
did you
has
call?
already begun to control its attitude. This is because when the distance between each other become closer, and when the distance is about 0.4 meter, each vehicle has stopped its control. I mean, the attitude has stopped it. As Mr. Xu has mentioned, when the docking procedure has been completed, then the attitude control will begin. And this time, it turned from the Shenzhou spaceships to Tiangong-2 laboratory. There is also another reason because the Shenzhou spaceship only have the propulsion system to control the attitude. But for the Tiangong-2 space laboratory, it can have control moment gyros, which only use electricity and do not waste any propellants. So that is why it can stay in space for a long period, because it do not use any expendable resources.
After all, you have to save that power and energy for Shenzhou-11 to return
天
to
空报
Earth.
告，组合体
Yes,
消除
saving
烟
in
持
the
续
energy
正
and
常
Saving
propellants.
energy for 30 days later when the Shenzhou-11 will be returning
And
to
in the
Earth.
future, they will the Shenzhou spaceship will dock with the station and stay there for 180 days, half a year. So it is very necessary for it to saving the propellants. That is very critical.
And that process will test China's ability of its own cargo transportation as well as refueling capabilities by then, Professor Yang, right?
Yes, and there is a noticeable point that the Tiangong laboratory is also a rudiment of the future cargo ship. The size is also very similar, but it will be much heavier because you know that Tiangong is empty inside, but the cargo ship will full of cargoes, the food, the oxygen, the water, and other supplies.
But right now, on board Tiangong-2 are a series of experiments that are waiting our two astronauts to do and bring back some of the experiment results to Earth. So tell us a bit more about Tiangong-2. What kind of scientific experiments are on board?
Well, there are many interesting scientific research experiments on board the Tiangong-2. One of them is the ultra-cold atomic clock, as we mentioned before. You know that's the main payload of the navigation satellites are atomic clocks, which keep its very precise time. So every day we use our mobile phone and we have a navigation module in our mobile phone, and we can go anywhere very conveniently. That depends on the signals of the navigation satellites. But the accuracy of the navigation satellite now is about the error 1 second for every maybe several hundred thousand years or several million years. But for the ultra cold atomic clock, the error can reach to 1 second per 30 million years. So that is more accurate than before. If it can be successful, and in the future, the improvements of navigation satellite system will be improved.
北京明白。
I think that's a veteran astronaut there, Jing Haipeng, saying that they're standing by.
You can see, as Mr. Xu has mentioned, Mr. Jing Haipeng is in the middle of the seat. That's the position to operate the manual docking, and also there are handles on both sides of his hands. One handle is to control the relative position, and the other is to control the attitude. So, as Mr. Xu has mentioned, this is the duty of the Shenzhou spaceship to using its propulsion system, mainly the attitude control engines, also some small engines to change its position during the docking process.
Now, veteran astronaut Jing Haipeng has 3 times of experience in space right now, but the docking process, especially the preparation, the practicing of the docking has taken thousands, if not tens of thousands of times there on the ground not only in Jiuquan, but also in Beijing, the training center. Tell us more about the preparation, especially the training.
You know that in Shenzhou-10 mission, Mr. Liu Wang performed the first manual docking of China. His operation is so perfect. I mean that you know that after the capture of the capture rings, there is a procedure called the forced alignment. The forced alignment, when pulling together the capture ring, will force the two vehicles to eliminate the errors, the attitude errors and the position errors. And the first time, the manual docking of Mr. Liu Wang, because it is too accurate, so this procedure is omitted. So the whole procedure, usually it takes 10 minutes, but that time it took less time than this. And as you mentioned, Mr. Xing Haipeng must be the backup of Mr. Liu Wang, because in
天空报
every
告
mission,
组合体消除篇完成。
okay, the error has been
Corrected.
omitted, so corrected.
长城报告，申请发送 B136翻板起控指令。
Okay, the rotational mechanism of the solar panels or the SADA can continue to work.
Now, at this point, we can safely say that the docking process is a success?
The last operation, as mentioned by the flight control center, is because that during the docking, the solar panels must be in a horizontal position to avoid the influence to the optical sensors. So after docking, it can work continue.
Now, the docking process is only the first step of the whole mission taking place this morning here in Beijing. What are the next steps?
The next step will check the status of the pressure of the both cabin. You know that during the docking procedure, to keep the safety, the hatch between the orbital module and the re-entry capsule are closed to avoid any collision. If any collision happened to the orbital module, so the re-entry capsule still is safe. So at this stage, because the docking has been already very successful, and the next stage maybe after checking of all the status and also do the necessary switching of the buttons.